Hi, everybody. My name is Isaac Evans, and today I'm going to be presenting about writing robust Flask and Django applications. I'm going to give you a little bit of my background to start off with. So my name is Isaac. I'm the co-founder at a small company named R2C, and we're a static analysis startup based in San Francisco with a mission to profoundly improve software security and reliability. Of course, these days, we're a little bit more distributed. You can see some of our team there on the Zoom matrix. And I'm really excited to share with you some of the things that we've learned about writing robust Flask and Django applications in particular. I won't leave you hanging. If you're the kind of person who wants the TLDR right up front, here's what it is. The first thing actually is just to read the documentation for your framework and try to stay up to date. So we'll link the slides for the presentation, but there are both Flask security documents and Django security documents, which are quite good. The second point is that it's so much more effective to favor secure by default frameworks and architectures rather than trying to hunt down every possible vulnerability in the corners of your application. And the last point, and one that is especially near and dear to my heart, is check your code with code. As much as you can, automate the stuff, and make it so that not everybody on your team has to be an expert. So I'm going to be using an open source tool, SimGrep, which me and my team actually maintain, which makes it really easy to write checks for code. The SimGrep rules that you write actually look a lot like the Python code that you would be searching for. And so we'll see some examples as we go through some of these best practices and like things that can lead to security techniques that are actually interactive exercises where you can write these checks or just like deploy a check that I write in these exercises and get started right away with something that you could just insert into your CI system. So when we think about writing secure Flask or secure Django, there's basically three parts. The first part, which we won't spend too much time on, but is really important, is you need some kind of security philosophy. If you just say, hey, like we're going to maximize security and we don't care about usability at all, you're not going to have a very popular website or application. And then the second piece is, all right, like what are the specific kinds of bugs that we see in these frameworks? And how do we go from the bug to the mitigation, or even better, the automatic detection of this kind of issue? And then finally, like how do we set it up so that it automatically scans every commit and every build as fast as possible? So let's start out by talking about security philosophy. There's seems like every day basically there's some sort of like fun new headline that comes up about someone who got hacked because like they were insecurely configured or whatever. And what happened? Like, what's going on behind the scenes, right? Like when you read these headlines, what's happening underneath? It's not always an application layer problem, and we're going to talk about that. But actually, like I'm going to show you two headlines that were actually directly related to things that we're going to talk about later on in the application. One was definitely Flask. The other one, it's not clear exactly what the underlying web framework was. So like this Netflix account compromise headline was caused by two things. It was the lack of clear text HTTP connections rather than encrypted HTTPS connections for some subdomains. And Netflix failed to flip on the secure flag for their session cookies, which would prevent transmission over those unencrypted connections. Similarly, Patreon got hacked a couple of years ago. They had a remote code execution vulnerability that was reported to them publicly before they were breached. They lost email addresses, postal addresses, hashed passwords. This is the kind of thing that it would be great to prevent from happening to you. And this one actually was specifically a Python web app. So what's interesting is that like these headlines often have in common very simple mistakes. It's not like it required some super expert security person to come in and like do a like deep analysis of the source code and like everything had to be rewritten. Very small mistakes ultimately, and very small fixes. And so our philosophy I think has to be that, hey, like we're going to make mistakes eventually when it comes to security. Like if Netflix can't get it right, we probably don't have much odds of getting it correct all the time anyways. And so that means that like whatever we can do to kind of just like lower the bar around the entire application is going to be better than like, well, the authentication is just like super secure and super well written. So this is kind of my security philosophy, is that like it's better to do a little thing consistently than to do like one thing really well. So the other way you can think about this is that a short but complete wall is a lot better than an isolated tall gatehouse. So that, I promised we wouldn't spend too much time on the security philosophy, but now you know a little bit about what mine is. And let's dig into, when we talk about like applying this to a web framework like Flask or Django, what does that actually break down into? So here's a kind of overview of the stack that you might look at from an attacker or a defender's perspective, and what's your responsibility versus what's other people's. So at the bottom here, you've got things like the operating system, you've got like the C standard library, whether that's libc or musl or crt on Windows. And then of course, Python is all, Python is just a programming language specification. The specific interpreter that you use to run Python actually matters. You're probably using the CPython implementation. And for everything in the bottom three layers here, the good news is that really you just have to keep it up to date. So whether you're using a container or whether you've installed these things on your server, as long as you keep up with the patches for these things, they're automatically going to get security updates that should be reflective of, if somebody is running around exploiting these things in the wild. As long as you're installing the security patches at a fast cadence, you're going to be fine. What is your responsibility is your application, the like app.py and all the other files along with it, as well as the built-in or third-party libraries that you've installed. So if Django has a security bug, you're going to have to like repackage and reship and redeploy your application. If you're using some third-party library to go along with it, you're also going to be responsible for that. And so like this, great, we've defined our area of responsibility. Now it's kind of overwhelming. Like we've got like all of these things that we need to protect. How do we actually break down like what are the most common ways that somebody who's going to try to break into our website would do it? And fortunately for this, we have some like great resources that are in the public domain where other people have gone through and actually created ontologies of the sorts of attacks that can be used to penetrate a web application. So the two most common by far are the Open Web Application Security Project, or OWASP, top 10. And there's also a project by the MITRE Corporation called the Common Weaknesses in Information, or CWE. That's much more extensive. It's used by, like if you were protecting something and like employed by the government, that's probably the one you would look at. But for today, we're just going to focus on that top 10 from OWASP. And so I'll give you a second to read over the list, but I'll go over them just at a high level. And we're only going to have time to talk about 3 today because this is only a 45-minute presentation. I would love to go through the full thing. The first one is injection. And this is basically oftentimes the conflation of data that ends up getting interpreted as code. So, like the user submitted something, it shouldn't have been executable, and then somehow it became executable, whether it got like written into JavaScript context or like something weird happened inside a buffer overflow. The second one is broken authentication. That's pretty obvious. Third one is sensitive data exposure. Again, that's like, ooh, we accidentally logged something out to the user that we shouldn't have. We forgot to redact this field. The fourth one is a little bit maybe obscure, but is still really nasty, which is external entity expansion in XML. Fifth one is broken access control. And then after that, we've just kind of got the works security misconfiguration, cross-site scripting, which if you've ever done any web security work, you're probably very familiar with, insecure deserialization, components with known vulnerabilities, and then insufficient logging and monitoring. So today, I'm going to walk you through 3 of these and then show you how a static analysis tool, something like SymRep, could be used to prevent some of these attacks so that not everybody in your entire team has to be an expert and get it right 100% of the time. So let's start off by talking about injection. Here's what OWASP says about injection. There are a ton of different types. This is why it is the most common issue category. You've got SQL injection, command injection, header injection, template injection, blah, blah, blah. And even if you're, you might be most familiar with this from a kind of SQL perspective, but it's not just SQL. Like anything that is involving sending commands to an external system that is like, or a system which has appropriate power to be interpretive, like eval, is potentially vulnerable to injection. But because SQL injection is the most common, I'm going to walk you through that, and then we'll talk about, what are the sorts of things that people do to just make this a non-issue in their entire application. So here is an example in Flask, and let's imagine that the user and password fields are user controlled, which kind of makes sense. Those are coming directly from our web form input. And you can see we're putting them directly into our web application query string here. So inserting user-defined strings into a SQL query is super dangerous. And if you already know why, and you know what the problem is, you're probably wondering what's taking me so long. But just for the benefit of people who maybe haven't seen SQL injection before, what if the input looks like this? What if the value of user is a string that has apostrophe or 1 = 1, semicolon, quote, dash dash, which would be a comment in SQL? Well, the dash dash in SQL is going to trim out as a comment the rest of the interpolated string here. And what we're actually going to get is a query to the database that says select from users where name equals empty string, which is never going to be true, hopefully, or 1 = 1, which is always going to be true. So now, instead of just returning a single user that corresponds to the username and password, we're actually going to get access to the entire database of usernames or passwords. And depending on how this is being rendered back to the front end, that might just be directly shown to the user, which is obviously not great. Now, the weird thing is, like, this looks kind of innocent, right? If this was, your first time writing a web application, you probably would see this on Stack Overflow in some book. And so, a consistent theme throughout this presentation will be that, like, sometimes the most obvious way to do things is a big gotcha when it comes to security. Like you were like, oh yeah, of course, like that seems totally fine. Like, what could the issue possibly be? And then it was like a trick question, oh, it's actually horribly, horribly insecure. And so I think, this is a really unfortunate reality about the way that security is presented to a lot of people. It's just kind of presented as a bunch of like, well, like you tried so hard and like, here you were just trying to write your web application, like make the thing work. And then there are all these security gotchas. But in this case, the fix, there's basically 3 levels of fixes. So the first one is don't use SQL. And that might sound trite, but there are object relational mappers, also known as ORMs, which are by far the kind of like preferred way to resolve these kinds of issues. And in that kind of case, instead of like directly like constructing the SQL query, you'll let the library construct that SQL query for you. And the libraries have been designed to not be vulnerable to these sorts of injection issues. So you'd say something like user.get. The second solution, which is still technically correct, but maybe not as preferable, is to maintain a clean separation between the code and the data. So parameterized queries. And in this case, you can see we're using this question mark syntax inside SQL. And even though it looks like, maybe you're looking at this and then you're like, well, how is that different? Like, isn't the database just going to copy whatever is in this like query ID string right into where that question mark is? And the answer is actually no. Like the query that ends up going to the database, if you looked at the packets, it's maintaining the separation between your select star where ID equals question mark and the parameter that goes along with that all the way to the database. So there's never any confusion about what's part of the query and what's part of the data that goes along with that query. The third thing, which maybe you expected me to say, like if you've ever talked to a security person about these sorts of web application issues, is like, oh yes, we just have to remember to sanitize all of the user input. Honestly, I really don't recommend this as an approach, because the problem is that you have to remember to do it everywhere. And it clutters up the code. You have to get it right everywhere. And then also, sometimes it's not obvious like what exactly you should be sanitizing to. So what's safely sanitized for one database might not be safely sanitized for another database. What's safely sanitized for one browser might not be safely sanitized for another browser. So it's kind of a moving target, and certainly not a principled approach. And then the last thing is like, hey, like if you had some kind of policy where you've agreed hey, like this is how we will fix these kind of issues. Like, you know, we're just not going to have SQL injection issues in the application. You should try to set up some automation that prevents merges to your main branch that sidestep any of those above examples. And actually, we have been working with Jacob Kaplan-Moss, who is one of the co-creators of Django, has been consulting with our company to try to write some symgrep checks that can help with these sorts of issues. Cool. So that was injection. We could have spent more time on it. It was kind of a whirlwind introduction, but there's a whole bunch of other things to cover, so I wanted to keep moving. The next one that we're going to talk about is the 6th from the OWASP list, and it's about security misconfiguration. These are great issues to talk about because they're often only 1 or 2 lines, and so they're an easy thing that you can automate, but they're typically very high impact. So let's look at a quick example. Here's a security misconfiguration issue. This is like your most basic Flask application. What's the potential problem with this? I'll give you a second to think about it. So definitely this is fine to run while you're developing. The problem is that when you have the debug equals true flag, it will open up a debugging console whenever there's an error. So as long as your application never throws an exception that isn't unhandled, you'll be fine. But if you did throw an exception that suddenly popped up with this debug equals true flag, the user would then be given a console that lets you actually just run arbitrary commands on your server. So that's not great, obviously. You know, like giving the user a Python CLI shell in the web browser that can just run arbitrary commands on your server is not great. Again, we talked about this earlier, but this is believed to be how Patreon got hacked back in 2015. And they have actually made some changes here. There's now like a 4-digit PIN, I believe, that is required to get access to that shell. But it's still a huge risk. I remember talking with somebody about Facebook a few years ago, or about this with somebody at Facebook a few years ago, and they were like, "Oh yeah, like I just found this issue. It's crazy, but that's the default behavior." So how do we find that kind of issue? I'm going to show you. We're going to pop over to a playground for symgrep, which is going to let us basically come through and write a little code snippet that should find this kind of issue. So here's a full Flask application, and what we want to do is basically say, oh, okay, like if you're running like app.run, that's fine. If you're running app.run with debug equals true, that's bad. So I'm going to copy this code here, and I'm going to paste it into the query box. And even though we're doing this online, symgrep, you can download it, you can run it offline locally. In fact, if I click the share button over here, you can see how we can pip install it, and then we can just like run it with this config, or if we switch over to the advanced view, we can just grab the YAML editor. But what I'll do is I'll basically say, okay, like anytime we see app.run with the string and debug equals true, I'm hoping that that will trigger. So I'm going to run this, and boom, we've successfully triggered on line 19. You can see that we had a message here. It's basically saying to the developer, hey, I detected a Flask app, debug equals true. Please don't deploy this to production. So that's pretty cool. And like again, I could tweak this a little bit. I could we should be able to see that if I put like an empty string here, it doesn't match. We have a ... operator that if you're like, well, I don't really care what's inside that string, I can use that, and then it will still trigger even if I change this to like O.1. So pretty nifty, and there's a tutorial and everything for this. But let's get back to like the security misconfiguration topics for Flask. So there's an example of how we could audit for this kind of issue. Let's look at another potential security misconfiguration. So here we're creating a route in Flask. We're going through and like creating a session for the user inside this login route. Seems very straightforward. What are the potential issues with this? And there's actually not just one, but potentially 3 issues that we could discover with this kind of setup. So I won't keep you in suspense for too long, but these issues are basically, hey, this cookie could be requested over an HTTP connection, not HTTPS. It could be vulnerable to cross-site request forgery, and it could be read via JavaScript, which can basically be, it's not a vulnerability in and of itself, but if there was any kind of cross-site scripting or XSS in the application, that would allow us to expand our impact and steal user sessions. So, it's not necessarily the exact code behind this Netflix vulnerability, but this is the sort of thing that definitely does happen. And it's a really easy thing to avoid if you're willing to like write some automation to check for it. Again, this is just another one of those gotchas where like unless you knew that this was an issue that could happen with cookie setting, it's not necessarily something that would be top of mind or you would get any warnings about when you're developing your application. So specifically, the fixes here are that like Flask has a bunch of recommendations for session cookies. So you can see these 3 flags that we're setting here. We would want to make sure that anytime we're manually creating a cookie, we would have those flags set. And we would want to prevent merges to our main branch whenever we have the secure and HTTP only flags set to false. So again, like, hey, like how can we automatically audit for this kind of issue? So I'll show you a cool little snippet. We'll write an example of what it might look like. And so what I'm basically going to say is, okay, I want to do anytime we call this like Flask set cookie, but this R object here, like it could be named something else. So you can see I'm importing it. I'm going to paste this, and I'm basically going to say, okay, whenever we have flask.response.setCookie, and I'm going to use that ... operator to say, yeah, I don't care about the first arguments. I want to trigger when, let's just do if secure equals true or HTTP only equals true. And I'll want to say that things can come after that as well. Great. So now we've triggered on, oh, I'm not sharing the screen here. I'm sorry. All right, I've switched the tab over. Thanks to my co-presenter for letting me know. So what I've done is I've just gone through and we've got like this snippet of Flask source code. I'm trying to find the example where the cookie is set securely. So the R object here, if we go up to the top, you can see Flask import response as R. So I put flask.response, and the SymGrep tool, it's kind of neat, has figured out that like, oh, like R is of type flask.response. So when I write this, even if I did import it as R2, and I put that in here, we should still trigger. Okay, nice, yep, looks good. Now the last thing is, okay, so I'm triggering on the secure case. I actually want to trigger on the insecure case. And so what I'm going to do is I'm just going to copy and paste this, and I'm going to add another line, and I'm going to basically say, oh, okay, like I want to trigger whenever this actually is inverted. So I'm going to find all instances of this set cookie function, and then I'm going to trigger whenever we're not showing these secure flags being set. So if I run that, we should see that now we're actually triggering on lines 8 and lines 13, which is exactly what we hope for. We're not triggering down here on line 26 because this is actually a secure setting of the cookie, but we are doing it where people are not properly setting these flags. So cool. Hopefully that gives you a little bit of example of why we like SymGrep as an open source thing. It's just super easy to kind of define these queries. And then actually, like I was just using the live editor here, but there's no magic behind it. It's just generating a YAML file, and if I wanted to put a message like please set secure, thanks. Now when I run that, that message should pop up alongside the output. Cool. And there's a question about, is there any off-the-shelf SymGrep rules that are already available? There are actually a whole bunch. So if you go over to the rules section, there's a bunch of packs of rules that people have written, for JavaScript, for Python, for finding secrets, for XSS. And you can see actually that we've got a pack of rules for Django and a pack of rules for Flask that you can check out later. So this is just at symgrep.dev is the site that I'm showing you. So coming back to the presentation and moving right along. So we've covered, obviously there are many more ways that things can be misconfigured from a security perspective. But we've covered 2 of the ones that I think are the most interesting for a framework like Flask. And the last one we're going to talk about is cross-site scripting. So if you haven't heard of cross-site scripting, it is a plague on most modern web applications. And basically what goes on here is the user puts in some value that is supposed to just be like their name. And you rendered it back when you created the page, but potentially like their name was actually a script tag and it had JavaScript inside it. And then you started running JavaScript from your user on your web application, which was actually not great because that JavaScript, as we mentioned earlier, could go around and pull other people's session cookies, send them off to some evil server. And it's super effective, basically. So this is a very common web application. Let's take a look at what that might look like in a templated Jinja, like the templating language that folks like, well, Django uses Django template language, but it looks similar. So what's the problem with this in our template for our web application? So I'll give you a second to look at it. It's not too hard, but let's imagine that value here was set to on mouse over equals alert XSS plus document.cookie. So, well, this example actually should be corrected. We would need to have an actual element inside here, or this should be like a tag attribute rather. But what's going to happen if value was being used as an attribute of, say, the li class, was now the user submitted JavaScript, potentially, if this came from user input originally, is going to execute this command. And so instead of just popping up a box with the cookie, you could send it off to some other evilwebsite.com, and then that person would have our user's cookie and be able to browse the web as them. Obviously not great. So one of the pieces of good news is that both Flask and Django will automatically configure Jinja 2 to automatically escape values unless they're explicitly told otherwise. But that's not the end of the story. There are a bunch of other places where you have to be really careful. So these are some of those places. And there's also, as we just saw, unquoted attributes inside the HTML structure that can be dangerous. And so in addition to those, some of the gotchas are that your template files have to have the HTML extension in order to be safe. So if for some reason you were rendering out HTML as like HTML2 or TXT, but then the browser was interpreting it as HTML, you would not, all of a sudden you would lose these benefits of this auto escaping. And there's a couple other caveats. Again, I would say these are just kind of some examples of gotchas when it comes to cross-site scripting. Let's dig into one of them really specifically. So here is an example of what's safe. So imagine we're calling our render template function, and you can see we're passing in the argument from the user, like whatever they've put in as the query parameter for hello. So if you look closely, you'll see hello equals, and we've got this script thing. And when this renders out to the user, this is great. This is exactly what we want. It's just rendering the literal text. It's not actually interpreting it as a script tag. But if we use render template with unsafe.txt as the output, the browser will still interpret it as HTML, even though it on our server had that .txt extension. Now, instead of being neutered and just displaying text, it will pop up a box where we're actually executing the arbitrary code from the user. So this is not great, and like a lot of work has been done over the years to try to make XSS less of a problematic issue. The kind of like when we talked about SQL, I would tell you that the #1 recommendation is to just use a web framework like React, which is designed explicitly to be less vulnerable to XSS. So this is one of the design goals at Facebook of that tool. The other thing that I would recommend is always using the HTML extension for templates. So easy thing to just like search, use grep or sendrep, look for render template. We actually already have a rule that's written for that where you don't have an HTML extension. Another thing you can do, which is not guaranteed to solve your problems, but could work as a stopgap, is to set the content security policy for your application. So that basically says like, hey, only We'll only run JavaScript that is served inside, like explicit script tags, none of this like on mouse over stuff. And the other things you could do are use some other tools like Flask Talisman that have been explicitly designed to harden against these sorts of issues. And in fact, Flask Talisman, we'll just go look at that real quick. This is a Google Cloud project, which basically adds a bunch of HTTP security headers for Flask. So it's kind of designed to take like a lot of this advice and just package it up in a framework that you can start using immediately and get a lot of benefit from without a whole lot of work. You can see that you just import it and then you wrap your Flask application in it, and it automatically does these configurations. And again, just telling people on your team about these is not necessarily going to make any changes. Really, you want to set up some kind of automation to be able to prevent merges to master that violate any of these above properties. Great. So, it's been about a half hour. We've gone through 3 of the 10 top 10 OWASP. I have to tell you, unfortunately, that there are more to OWASP. So we've been looking at OWASP top 10 for web apps. But in fact, there is a whole nother list for APIs. There are lists for like backend programming. And maybe at this point, you're like, oh, this is why I hate security. It's just full of gotchas, and I'm kind of ready to throw in the towel when it comes to security. So this is why we have the third part of the presentation, which is how do we automate all of this so that it doesn't become such a pain to try to remember all of these nuances and minutiae. And broadly speaking, when we think about automating, there's a couple different kinds of tools that we can use. So the first one is, we talked about this with React or with using object relational matchers. ORMs, object relational mappers. Using languages and frameworks that are secure by design. So for instance, the fact that you're writing in Python generally means that you're not going to be vulnerable to the sorts of buffer overflow vulnerabilities that you would get if you were writing in a language like C. If you're using an ORM, you shouldn't be vulnerable to these sorts of SQL injection issues that would plague you if you were writing SQL directly. So that is obviously the preferred approach. Another one that I really like is static analysis, which is basically, hey, like we automated the sorts of things that we would hope people look for when they read this pull request, and we have a bot that goes through and comments on them. Beyond that, there are things that are even more advanced, like formal methods, which can actually not just kind of like find issues or enforce guardrails, but can actually give you really powerful guarantees that like, oh yes, like we can actually construct a proof that this web application is not vulnerable to this kind of attack. That's generally outside the reach of most web application developers, but you see it a lot more on the kind of like aerospace or government side of things. There's also dynamic analysis, which is kind of like, well, like, let's use something like Burp Suite and like just throw a bunch of inputs at this application and see what happens. And then beyond that, there's an even more general, of course, thing, the letting people poke at it, which I think is popularized by the idea of bug bounties. These are actually great because you're basically saying, hey, like I will let anybody in the world poke at my application. If they manage to find something, I will pay them for it. And that can be very efficient as well. So, when it comes to secure by default frameworks, I already mentioned some of these, but just to give you a roll-up, I would recommend something like SQL Alchemy for your Flask or Django application to avoid SQL injection. It's a decent ORM for Python. It's not foolproof. There's still ways to have SQL injection with it, but it will help you out a lot. For XSS, many modern frameworks have mitigated XSS by default. I know there are sort of pros and cons to all of them, but from a security perspective, React is definitely the best. And there's more detail I could go into on it, but it comes from an explicit design goal at Facebook, trying from their perspective to reduce the amount of XSS. On the topic of XML vulnerabilities, there's a library called Diffused XML, which is a great name for Python that I would highly recommend. And some of the other issues, like just picking the kind of technology that you use for authentication, like using JWT, JSON Web Tokens, instead of cookies, can also avoid a lot of these issues. JWTs do have problems of their own, but on the whole, I think they're an easy way to recommend. And what makes some of these things better than others? So looking at like, kind of what do we want out of a secure framework? I think that a good secure framework, like the kind of most basic thing you can do is be like, oh, programmer, you are doing this thing. Please don't do that thing in a production environment. But they don't really talk about the impact. A better thing to do would be to say in the warning message or wherever, hey, don't use this in a production environment because you're going to get hacked. And the best thing that I've seen frameworks do is basically say, hey, we're going to put all the most secure options on by default. But if you run with this super scary flag, we will remind you that you're opting out of some really helpful security protections. And we don't want you to forget about that. So for example, I think Flask actually does a poor job of this when it comes to things like render template string, which does not actually safely escape things, versus render template in Flask, which does safely escape things. I feel like even after I said that, I'm starting to forget which one was the secure version and which one was the insecure version. A good example is in React, there's a function called dangerously set inner HTML, which is a replacement for the jQuery function inner HTML. And it's meant to emphasize that, hey, you probably don't want to be doing this. This is something that is highly likely to lead to XSS. You should avoid doing it if possible. So we talked about frameworks. I also promised I would talk about static analysis tools. I actually see a lot of teams using grep to spot things. Like if you're looking for dangerously set inner HTML, that's very easy to grep for. There are also tools that are designed specifically for Python, not necessarily for Flask or Django. Bandit and dlint being two of the ones that I know best. There's also linters like Flake8 and its associated plugins, which sometimes have rules that can be effective for Django and Flask in particular, but usually more generally for Python. SymGrep, which is the tool that I work on, has about 150 checks for Python today. And I think I mentioned that if you go to symgrep.dev and click on rules, you can find some pre-built packs specifically for Django and Flask. And then there are, of course, proprietary tools like SonarPython and commercial tools that you can buy, but they tend to be quite expensive, and so maybe not as obvious of a choice for a team who's just trying to get something set up into a CI flow. In terms of where you should deploy these things, as early as possible is the best. So ideally, somebody runs git commit, and you have a commit hook that's going to run and identify oh, interesting, that's not the kind of thing that we want to be doing. Did you know about that? Obviously, if you can put it in the editor, that's even better. But I also see a lot of people deploy these sorts of checks at the pull request stage. That tends to be pretty common as well. So in conclusion, as promised, we came back to the TLDR for the talk. Reading the docs for your framework and staying up to date, there's really no substitute for that. If the attacker knows more about the documented gaps and holes and weaknesses in your framework than you do, they're going to win. And they only need to win once. The second thing that we talked about is basically favoring secure by default frameworks, so things like SQL Alchemy and architectures. Basically looking for things that, yep, they've turned on all the security things, and I have to explicitly turn them off in order to opt out of those security guarantees. And then the last thing is checking your code with existing toolkits like Flake8, Bandit, or dlint, or write your own custom static analysis or use some of the queries that we've written with a tool like SymGrep. And if you enjoyed the presentation or you have questions, things that you wish I'd addressed, I would love your feedback on the presentation. So r2c.dev/survey has a form. A lot of people have already filled that out. So if the presentation was any good, it was thanks to the feedback of people like you who went through and did the survey. So I'd really appreciate that. I wish I could be there in person, of course, but due to COVID, so we're getting close, not quite to the point where we can do that traveling. But yeah, looking forward to catching up with your questions.